Hi everyone, welcome to Past Business Intelligence Virtual Chapter. My name is Julia Cosmano. I'd like to thank our sponsor Pragmatic Works today because they are actually helping to make this event happen. And we also have ebook to give away, and that will be picked in random, so I'll notify the winner probably at the end of the month. So just some news around Past community. I just want to thank everyone who actually submitted the feedback for our Past BI virtual chapter. So congratulations, Donald Paris, who won the Surface Pro giveaway from January feedback campaign. And I'd like to remind you as well that we do have session recordings on our YouTube channel. So this is a brand new one. We've already uploaded 15 hours of free learning there. So just go ahead and check them out. And we'll hopefully be able to upload the later session recordings as soon as we can after the broadcast is done. Upcoming in March and April, we do have a number of SQL Saturdays in North America as well as international events. So I'm actually helping out the ones in SQL Saturday in Melbourne. So that's actually really, really exciting. So if you're actually based in Australia, you might want to check that one out because I think that might be the first one that we have this year around the Australia-New Zealand region. And just a reminder, we do have a number of virtual chapters out there, so be sure to check them out if you're interested. And there is a SQL Server 2014 launch. So I think the BI virtual chapter has just hosted one, and we do have one for business intelligence as well, which is on the 13th of March 2014. And so this series are actually specific to the topics relevant to the virtual chapter. So make sure that you check it out. And so here are the past virtual chapters listing. The number has grown. So if you're interested in particular areas such as PowerShell, then be sure to check out the virtual chapter 2. And if you're interested in volunteering with PASS, don't forget to go to your My PASS profile under the My Volunteering section. Just make sure that you update that properly. And just a reminder, we do have PASS Business Analytics Conference on May 7th to 9th in San Jose, California. And if you haven't registered, we do have a discount code BAVC05, and you get $150 off. So make sure that you use that to take advantage of the discount. And if you'd like to stay involved, don't forget to go to sqlpass.org and just follow us on Twitter as well. We do have a Twitter account. It's at PassBIVC. So without further ado, I'd like to welcome you to today's session, SQL Server Reporting Services Disaster Recovery with Denny Lee and Ayat. I think you're in for a treat for this one. So I'd like to hand over to Ayat now. So if you bear with me for a second. Okay, I think this screen is looking good, Ayat.
Okay, Denny?
Oh, actually, you know what? Oh, there you go. Perfect. I apologize. Slight delay on my side to actually see the screen. My apologies. So, hey, everybody. How you doing? My name is Denny Lee. You may know me from my days at Microsoft. I'm actually off, and I ended up joining Concur. So, how you doing, everybody? And Ayat Shamut, why don't you introduce yourself, excuse me.
Hi, everybody. This is Ayat Shamut. I'm a SQL and BI independent consultant and a Microsoft MVP as well.
Cool stuff. So we got that out of the way. All right, let's jump right into the agenda here. Excuse me. Okay, so basically today we are talking about reporting services disaster recovery. But before we get into that, we need to talk a little about scale-out architectures and the importance of the reporting services catalog. That's actually how we're starting off with. Then we can dive right into the disaster recovery infrastructure and also a little tidbit about how to optimize the catalog with SQL Server 2012 always on. So that's today's agenda. I hope you will enjoy it. Next slide, please. All right, so this is, for some of you who have attended IAD and my presentations in the past, this is going to be a little bit familiar to you guys. So basically, this is your typical reporting services architecture with a one-box deployment. Okay, don't worry, I will get into the reason why I talk about this in a second for disaster recovery. But if you look on the left side, what you have here are the clients. Typically, it's no, back to keep the previous slide if you don't mind. Sorry. On the left side, you have the clients, right? So they are all going to go ahead, typically through some networked load balancer, connect to, in this case, is one box, okay? It'll talk to a reporting server, and the reporting catalog is actually going to be on the same box as the reporting services. For development purposes, this makes a lot of sense, right? You have the reporting catalog, which basically is just a SQL Server database, and the reporting services, the web services that it generates to generate the reports that you see, all in the same box, and it's the one that goes ahead and talks to the data sources, whether they're flat files, ODBC, SQL Server, whatever else. That's actually how you get access to this stuff. Okay, so that's your typical one-box deployment. The green arrows and yellow arrows are just sort of talking about the data flow. All right. Next slide, please. Okay. The first thing we typically do when we want higher availability, because we actually want to get into eventually to the process where we have multiple reporting services boxes to take on the concurrent load of users, i.e., as you have more users accessing reporting services, what you can do is you can scale out reporting services, okay? So that way it can take on more web traffic. But before we do that, we actually need to move the report catalog, the reporting services databases, off of the off of that same one box. Mainly because as you have more reporting services servers being pinged from the various clients that are trying to access it, there's going to be more and more transactions that will happen against the report catalog. From the standpoint of all of you folks who are SQL Server DBAs, what's basically happening is that you have a lot of transactions that hit the report catalog. We'll actually get into the details behind them in a few slides from now, but the basic principle is that there are a lot of transactions that hit that report catalog. So unless we put that catalog on its own separate server, we'll basically completely inundate the server. And then once we inundate this server, that means reporting services will never be able to relay any information to you. Okay, so that's pretty problematic. Okay, so there we go. I think that covers that scenario. So next slide, please. All right, so now I'm some big company, and I have lots of stuff to go ahead and access, and so I got a ton of clients that are on site that are accessing the system. Again, they're hitting a network load balancer because they can evenly distribute the queries across multiple reporting servers. So if you look at the three that you see here, what you have is 3 reporting services servers, okay, in which it's basically those servers will ping the data sources to get the data, bring it back to the reporting services servers, and then display that information for the user to read, right? And so typically, why you at this point want a network load balancer in place is because when each user is going to go ahead and access the data, we're typically going to set up the network load balancer with something like cookie affinity. Basically, this is what you typically do with these type of switches, which allows that when a user goes ahead and looks at report on, let's just say, reporting services 1, when they click on, excuse me, when they click that report and try to access and drill down and things like that, what will happen is that because that report's already cached on reporting services 1, what should happen is that their subsequent clicks will go back to reporting services 1 as well. They won't be rerouted to reporting server 2 or reporting server 3. So that's the importance of the network load balancer. It allows us to ensure that the initial ping to the reporting services servers are distributed across multiple servers. So that way not a single server will get inundated with too many clients trying to access the data. But the subsequent clicks, because we've already cached the data onto the reporting services server, well then let's not go ahead and actually cache every single report over every single user across all 3 different servers. Instead, subsequent queries for the same data can in fact go back to the original server because the data is already in cache there. Okay, so that's what I'm referencing about cookie affinity in the network load balancer. It allows the user to round robin for the first 3. The initial query, it'll round robin between the 3. But then subsequent queries, it'll actually affinitize to the initial one it was able to connect to. So the importance of that is that you can now keep on adding more and more and more reporting services servers, because as you have more concurrent users that are trying to access the system, you're actually able to go ahead and just somewhat evenly distribute the load across all the different reporting services servers. So this is great when you have this scale out and high availability infrastructure. But one thing you'll notice is actually it's the same report catalog database that's inside that cluster. Okay, whether it was that one deployment, the high availability, or the scale out deployment, it's still ultimately a SQL Server database, the reporting catalog that actually has to have all those transactions. Okay, for this all to work, this is the heart of it. So, what is it in that case? So, let's talk about that for a second. Next slide, please. Perfect. Okay. So the architecture basically of this report catalog is two different things. The first thing is a report server catalog, often referenced as RSDB. It is the most important database because it stores all the report metadata, including report definitions, the report history, the snapshots, the scheduling of the queries. Okay? So in order for it to access everything, in order for you to know what the report definitions are, what server it's supposed to connect to, what user authentication, all of these things are stored inside the RSDB. Excuse me, please. Now, the report server tempDB is a second database, okay, that stores all the temporary snapshots while running the reports. So back to the scenario where if you are going ahead and querying, you have clients that are querying the reports, they'll hit a reporting server first. The reporting server will hit the RSDB to figure out what, looking at the report definition, what data source is supposed to ping. It hits the data source, grabs the data it needs, okay, brings the data back to the reporting server. That data is also stored in the report server tempDB. So the idea is that subsequent queries for that same data under the same security context, they don't actually have to go all the way back to the data source to get this information. They can just go ahead and ping the report server tempDB to grab it. Okay? So it is definitely short-term volatile data. In other words, this data might change over time, so we don't typically keep this data inside there very long. And from the standpoint of high availability and or disaster recovery, the key thing is actually the report server catalog, because that's the one that contains the report definitions, the report history snapshots, things of that nature. So if you're going to lose one, you don't want to lose the report server catalog, you want to lose the report server tempDB. Okay? Now, because of this, and because of, I've denoted the call out the fact that we have the scale out environment that's hitting the system, these databases can definitely be a bottleneck. Okay? And so you're going to apply so in other words, to help with those databases, you're going to optimize by applying standard SQL database techniques. In other words, what you typically do for a standard SQL Server database, the same thing's applicable here. Now, the key thing to note is that the catalogs, both of them in fact, have a lot of I/O and a lot of transactions. Okay. For example, if you're still using Reporting Services 2005, there are many inserts to the chunk data, snapshot data, and to the session data tables. In the case of Reporting Services 2008 onwards, there are many inserts into segment, and the majority of the transactions are to the RS tempDB. Now, a quick thing to call out is that the profile for these databases are quite different. And in fact, we're going to go into that right in the next set of slides. So next slide, please. Perfect. So what are some of the best practices for the system? Basically, you want to use a dedicated server. It's the same server as if you use the report catalog and use the same server as your standard reporting services server. This is great for small environments, but in enterprise environments there is far too much contention, okay, resource contention for you to do that. If you use the same server as the source databases, okay, you're still going to have SQL resource contention, whether it's at the tempDB, the plan cache, the memory buffer pool between the data sources and the RS catalogs. Okay, as your load increases, you'll need a monitor CPU, I/O, network resources, and buffer pools. All right. If you can reduce the resource contention by having a dedicated reporting service catalog server that itself you can tune, because what the call out is that the way your data sources are queried and inserted are going to be a lot different from the way the RSDB and the RSTempDB are access queried. So you actually want to tune them very differently from each other. Okay. So for this database, you also, or these databases, excuse me, you want to apply high availability and disaster recovery procedures like clustering, mirroring, log shipping to protect the RSDB. We will go into how to utilize always on a little bit later on, but we're going to use the more basic setup that actually is tried and true and tested with IH's team actually. We'll talk about that first. Okay, next slide, please. So if any of you have actually ever attended my sessions or my sessions, especially on analysis services or the ones that Thomas Kaiser and I used to do, I apologize in advance, but we have the slight obsession with I/O. Okay, and so I am going to continue with our slight obsession with disk IOPS. And if you have not, then it might sound new. For those who have listened to it before, again, I apologize. But basically, there's a pretty cool document called Predeployment IO Best Practices. It's all about improving the way reporting services or SQL Server works within the context of disk I/O. Basically what it boils down to is that disk I/O is the main cause of why things slow down. So the more we can optimize the disk I/O, the better. Now for some of you, you might want to ask me, because I talk about this within the context of analysis services all the time, do you want to use SSDs? Typically you don't need them for reporting services. Okay, so even though as much as I love SSDs, you probably don't need them for reporting services. If you do, I can possibly see them making sense of the RSTempDB because of how many fast writes, fast reads that are occurring on them at the same time. But since you typically are building SSDs for either optimal for reading or optimal for writing, but not for both, that's why it gets a little problematic, because in the case of the RSTempDB, it's very much optimized for the purposes of reading and writing, and SSDs are a little tricky to do that well, I should put it that way. Okay. So nevertheless, when it comes to the disks, you're going to have the preference is to have more smaller disks with faster rotation speeds, basically 10K or 15K RPM disks, versus fewer larger disks with slower rotations. Basically, the faster these things fly, the faster they're able to return the data back to you. And so that's why we really want that. And in the case of reporting services, the report catalog really does a lot of stuff, so we want to optimize this. And so we want to maximize or balance the I/O across all available spindles. In other words, you don't want if you've got, for sake of argument, 5 disks, you don't want just one disk to go hot and the other 4 disks to basically do nothing. What you're trying to do is you're trying to optimize it so that all the data extractions in terms of reads and writes are performed against all 5 spindles as opposed to just one of them. Okay? Typically, because of this profile difference between the RSDB and the RSTempDB, you're going to want to have separate disks. You have one set of disks specific for the database files of the RSDB and one set of disks for the database files for the RSTempDB, mainly because the RSDB has a lot of small transactions because it's report metadata. That's one type of profile, versus the RSTempDB, which has more but not as many as the RSDB, but larger transactions because it's trying to extract a lot of data out of the system. So very different profile. Okay. Simple one, pre-grow your databases. If you're going to distribute the DB files across the number of cores, do it at the ratio of 0.25 to 1.0. That way you can minimize allocation contention and easy to rebalance when new spindles or LUTs are available. Okay. And typically we're talking about RAID 10 versus 5, mainly because we're trying to go for performance here. Okay. So that's it for I/O. So for all you folks who are used to hearing me talk about it, it's okay. We're done. Next slide will be on something else completely different. Okay, so operations best practices. There's some key things. Like I noted, the RSTempDB is highly volatile, right? So the report lifetime policy of data is the session timeout value of 10 minutes. What that means is that basically that data, that report data, is basically held in RSTempDB for about 10 minutes for the session timeout, okay? I've worked with some customers where they've actually increased that number to 2 hours because in essence they want this to be a semi-permanent caching infrastructure. That is possible to do. It's just that when you do something like that, the RSTempDB can potentially become a very big bottleneck. So you have to have an even larger server with more NICs to be able to provide all that data back to you. The reason for some people wanting to do that is because it minimizes the number of times you have to hit the data source. So while that's really cool, where you basically are trying to minimize the times the data sources are being hit, the concern with this is that if you actually want more up-to-date data, in other words, because the underlying source data changes all the time, then the idea of increasing that lifetime policy of data is actually probably a bad idea. But if this data is actually, only updated once a day, and you actually have enough infrastructure, network support, disk size, optimizing the SQL Server that holds the RSTempDB, then yeah, in fact, it's actually possible to go ahead and increase that number so that way you can make it the Uber cache server, basically. Okay. And so, as noted by the slide there, there's a cleanup cycles minutes that guides the background cleanup thread. There's a background cleanup thread that goes ahead and clears out the data from the RSTempDB. And basically, there's another value cleanup cycle minutes that you can alter to basically tell it how often you're going to do the cleanup. Okay. So the data in the RSDB though, versus the TempDB is long-lived, so that's the one you should back up. These are standard links on how to back it up, restore. Don't forget to also back up and restore the encryption keys. That's a key call-out because there are often encryption keys stored within the database, mainly because it's so that way you can securely connect to other data sources. Okay. When maintaining RS catalogs, don't forget that these are, in fact, SQL databases, so reindexing catalog tables or updating stats may improve query performance, but you definitely have to tune and optimize accordingly. Okay? All right, next slide, please. Okay, cool. So the sizing, nearly forgot about this section. So, and how do you size for the database? Okay, now the standard, varies by number of reports published and number of history snapshots. In other words, this is just legalese for telling me, I'm not sure what it is, but here's the basic general rule of thumb. Okay. So basically, the general rule of thumb is that a moderate-sized report definition takes about 100 to 200 kilobytes of disk space. This is actually larger than the actual RDL, the report definition language that's stored, because it persists both the RDL and the compiled binary, both. Okay, and then assumed about a 5-to-1 compression ratio. In other words, if there's about 10 megabytes of data that's taking up, then the snapshot is about 2 megabytes in size. All right, so if you know that you're going to have a few hundred reports, you can basically use this general rule of thumb to capacity plan accordingly for the RSDB. Now, in the case of the RSTempDB, the variation is not by the number of reports or history snapshots. The variation is actually by the number of users who are concurrently using reporting servers. Okay, so in other words, the general rule of thumb, again, general rule of thumb, is that if you've got 1,000 users of your system, somewhere between a 10 to 20% are concurrent, or you have to plan for about 10 to 20% of concurrent users. So if I use 10%, then basically what I want to do is I want to plan for approximately 100 users who are concurrently using the reporting servers. Okay, so that's the general idea. And so the rule of thumb is that you have a 10 to 20% concurrency of user base. Okay, there you go. Actually, I just missed that. So if another 1,000 users, then max about 200 concurrent users if you're using the 20%. If most users are accessing those 10 megabyte reports, then you'll need about 400 megabytes of storage. Okay, so there's the math. 200 users times 10 megabytes, 5-to-1 compression ratio, 400 megabytes. Okay, like I said before, you want to calculate for the maximum number of concurrent users. So that's actually how you'll pre-size the RSTempDB. Okay, cool. All right. So the final thing to call out before we dive into disaster recovery, so there's been a little obsession on my part to talk about the report catalog, but the reason why is because while the report catalogs are super important for scale out, it's also super important for disaster recovery. In other words, if we don't make sure that these databases are in good shape, this basically will result in, we will never recover from that disaster. Although that data will no longer, that reporting services metadata, the snapshots, the scheduler, we won't remember that. Now, scale out does not equal disaster recovery, right? Scale out is just allowing us to have more concurrent users accessing the system. But and because we go ahead and prop that onto its the RSDB onto its own server, that allows us the ability to scale out. But being able to ensure the viability of the RSDB is what is ultimately needed for disaster recovery. So that's the difference between the two, just in case some people confuse the two. Okay, so just want to hit that one hard. Okay, so now here's the disaster recovery environment. Ayad, I think it's time to switch to you now.
Sure, thanks, Denny. Actually, I just want to call out something, as Denny mentioned, that scale out does not equal to disaster recovery, which is basically one thing. When we configure those scale out, each server has its own configuration, so there's no replication between reporting services server. So if you make a configuration change in one server of reporting services, you want to make sure you make the same changes on the rest of the reporting services and the environment. Just in case if you lose one of these reporting services, the front ends, the configuration are in sync with the others, and in that case, your application and your access to the reports remain the same. The other thing also for disaster recovery is once you install the reporting services and you create the reporting server database and 10DB, that's actually, there is a key for encryption. Via the reporting server configuration manager, you can back up the key. This is very important because if you happen to lose the backend server, SQL Server, and you have a good backup of your database, in order to recover and bring your server up and running, you need the key to restore the database, because all the data sources and the connection strings are stored and encrypted inside the database. So in order to restore the database and rebuild your reporting front-end reporting servers, you need the key. Otherwise, you may want to go manually reconfigure all these data source connections. So as we implemented this in the production environment, this is the typical structure of our reporting server, high availability and disaster recovery environment. On the left side, as you see, we have our primary data center, and on the right side, there's the DR side. We have a bunch of reporting server front ends, some in the main primary center, and there are a couple in the DR side. And we use a content switch between those reporting services. As Denny mentioned before, the network load balancer is good for round robin, so basically it will balance the load over multiple reporting services, but it doesn't really manage the failover. So if I have my reporting service on the left side got lost or had any problem, the network balancer, it will still be able to redirect connection to the other report server, but the content switch actually will allow us to do manual failover. So we can take the whole server, the whole site, failover to the other DR site. So that's, as we mentioned, on the front end on the reporting services, and the back end, all the database are in the cluster environment. So we have the primary server, in our case it's called Boston SQL 4. That's the active primary instance, and we have a passive instance with a clustered server in the primary data center. But in the DR, we have a standalone SQL server act as a mirrored server where we establish mirroring in between. I'm going to cover this in the next slides. So this is just a summary of what we are hosting in the primary side, the front-end reporting services, and with a failover cluster for SQL database. And on the DR side, we have a counted duplicate of the reporting servers and the backend as well. And this is for DR situation only. And for the network, as I said, we use the content switch, which will allow us to manage the connection and redirect connection in case of a disaster. So we maintain the primary IP, so we have the IP address is active in the primary side, so all the connections come to the left side. If we lose the left side, the primary side, then the content switch will suspend the active IP and will enable the DR side IP address, so all the users will be redirected, and this is completely seamless and transparent to the users and the application. For the database configuration, it is actually on the left side. It is within the primary side where we have the primary database. It's a standalone SQL Server participated in a cluster environment. And that's where we also have an active passive cluster where we have the active instance and another standby mode instance. In case we lose the primary server or the active server, automatically fail over to the passive instance. And that's where we have the content switch as well point to the backend SQL databases. One thing also to call out here is all our reporting services using an alias, so it's not using the actual physical SQL name. So the reason for that alias because the content switch will hold the alias with two IP addresses. One is the active, which is pointed to the primary side, and the inactive IP, which is the one for the mirror server and DR side. So in case of a disaster, which is I'm going to cover this in the next slide, the scenarios, if we lose the primary side SQL Server IP address will be suspended, and the content switch will enable the mirror server in the DR side. In that case, both sides of reporting services is automatically reconnected to the SQL Server using the alias, which is a DNS name. So that was the scenario of active-passive, which basically is, again, with a passive, you are not really utilizing that instance as it's in a standby mode waiting for a failure on the primary to fail over. The other option is active, where you have a bunch of active databases on the standby mode instance while the reporting services database is hosted in that server. So basically you will have active and active cluster hosting online databases while the other node acts as a passive node for the other active node.
Right, so actually just going the quick call out back to that slide here. Oh, actually, you know what? You're hitting this part perfect, so why don't we just go with that? Sorry, my apologies.
Yeah, go ahead, Denny.
Oh, sure. No, I was just about to call out that the advantages of active-passive failover, right? So in other words, in this case, I had got this awesome environment in which basically the Boston SQL 4 is the active server, right? And then we have this other RSDB server, which is the passive, from right to left here, okay? So this works well if the passive node is not overutilized, because what happens is that while the RSDB is passive here, there are other active databases on that server. So we're not seeing a scenario where basically you've got extra servers that are doing nothing. What you have basically is more like a passive server that is not overloaded. It's maybe at like 25 to 50% utilization. It's great to have a passive infrastructure so that if the active fails, hey, you're good to go. Not a big deal. And once it fails, you can switch over to passive, and you have a backup that will work. You get the active back online, and then it'll jump. That passive will go from 100% utilization back down to 50% utilization. So that's really good, okay? But it's not good if you're in scenarios where the passive node in reality has a lot of traffic or a lot of concurrent users, okay? This actually happens a lot in scenarios where you start with that, but you didn't plan properly, or more likely just that a lot of traffic just started coming through, whether it's to the other databases on the passive server, or just because your RSDB itself is overloaded with because your reporting service environment has become extremely popular. So in those cases, then we would definitely suggest going to an active cluster, so that way you don't feel completely like wham, where the servers are going to go ahead and be taken down from this. But if you're talking about systems in which you've built enough infrastructure, the active-passive is a great idea. Sorry, just wanted to call that out.
Okay. So here's that's under just one more slide on the configuration. So as we have the front-end scale-out deployments for reporting services, back in 2005 and 2008, we had the option of building mirroring between two databases. So we used that feature in our reporting server HDR design, where we have mirrored set up between the active database in our primary data center and the mirrored database in the DR side. We use asynchronous because there are synchronous and asynchronous, but for asynchronous, it's better for performance, so there's no wait on the front-end application to make sure all the transactions are committed to both sides, but maintain the async basically will allow the commit as well, but without the wait time on the application side to make sure that those transactions committed to both sides. So we take into consideration as well the connection between both sides, between primary data center and the DR side. So again, recommended way for us is basically, and for everybody, is to have a high-speed connection between both sides. So with the asynchronous mirroring, we have basically all databases are connected to all the reporting services, or the operation is connected to reporting service database. And as I said, it has minimal impact on the response time performance at least for the application side. So quick configuration on our side, as we have Boston SQL 4, that's our primary instance where we're using mirroring and the listener, both encrypted communication between, and our partner on the right side is Montreal SQL 4, that's our DR side. And as I said, with our content switches, we are using an alias. So Boston and Montreal is the physical names, but we're using an alias in order to do the IP switch between the both instances of SQL Server. So actually, due to the time, I'm going to just go quickly through this one, but because I have a bunch of slides to cover different scenarios. So this is about the initializing database mirroring, where you're taking a full backup and transaction log backup. And by the way, in order to set up mirroring between two databases, you need to set the recovery mode to full. So we're taking into consideration also transaction log backup. So taking the backup of the primary database and transaction log, we store them over to the mirrored databases. And there's a GUI based for setup mirroring, or you go T-SQL in order to set up mirroring between both servers. So these are the four major scenarios I'm going through with you today, and how we are recovering from different failures. So number one is where we have the data center reporting server go offline. So if I lose on the left the reporting services, because I have a scale-out deployment, so my NDR server is still up and running, and with the content switch, I will be able to switch my connection and point the IP address. Basically, again, as a content switch, I have an alias, which is in my case a DNS, and multiple IP addresses assigned to that alias, with one of them is active. So now in this case, it will deactivate that primary site IP address, excuse me, and enable the DR site IP address. And that will automatically, the users will be connected to the right reporting server on DR side, which basically has the connection to the backend SQL database. In that case, I'm recovering from that failure, and my users are redirected. Again, it's completely, we're trying to set up the whole different design here to make it transparent and seamless to the end users and application. So this is what we call it an automatic failover. The second scenario, where we have the active server, which is the SQL server, in the cluster environment goes offline. In that case, as we have the cluster set up, it's automatic failover, so the cluster will automatically fail to the passive node. The passive node become the active, and the reporting services in my primary data center will automatically reconnect to the passive node. And this is again for there's no DNS change name here, because the cluster manages the virtual network and will redirect the connection for the front end. So will be no manual process in order to bring the reporting server online again. And that again, that's my second failure scenario with automatic failover. Now I'm coming to more of actually losing the whole disaster. Actually, it's more of a manual, like what if additional failures happen, which is basically causing us to go to do some further manual processes in order to bring the other server online. So the third scenario here, we are assuming that we're going to lose the whole SQL cluster. In that case, my primary SQL Server environment in the primary data center goes offline, or it crashed or any reason. So what happened is now the reporting services on the left in my primary data center need to reestablish the connection. But because we have database mirroring between my active instance of my primary instance and the primary data center and the DR, so we will be able to manually fail over to the DR mirrored server. Remember, because we have we have a cluster environment with automatic failover, I can't really set up a database mirroring with with automatic failover. The reason is, in that case, you're going to run into a problem like who's going to do the automatic failover? Is it the cluster or the mirroring? And you might end up into a failing problem. So we decided to give the priority to the cluster for automatic failover, but manually failover to the DR side. And this is, again, according to the SLA, the service level agreement with the business users, how long they can tolerate to have the server down, or how much time they can, tolerate in order to bring the server up again. So in our case, there are certain application, it's a 1 hour downtime. Other application can be up to 24 hours. So with this scenario here, where we're failing now automatically, not automatically, manually failover, and reporting services in my primary side now is connected to my back-end database in the DR side. With that, it's a manual failover, so we have to manually run a command in SQL to make the merge server become the primary server, or the principal, and that will be acting as a merge server, as the principal server. Once my previous cluster environment come up online, then reestablish mirroring, and all the changes made to my mirror server will be resynced with the active server in which is my cluster environment in the primary data center, and then I can do another manual failover to make my databases in the cluster environment as a primary. So what if now my third scenario is if I lose the whole data center, the front end, the back end, so my whole data center is gone. What we do again, it's another manual failover process. What we do is using the content switch, it's manually changing the IP address to make my DR side reporting server the primary. And the same thing we do, which basically do a content switch change where we have the primary, suspend the primary address and activate the DR side IP addresses for SQL Server. And that becomes the active. So the users will come through that switch, and the switch will redirect them. Here's my front-end reporting server as a primary server, and the back-end SQL Server as a primary as well. And with that, actually, for planned or unplanned outages, it's kind of the same process for us if you want to do some maintenance. The only difference for a planned outage, we will be able to manually switch running a script to make the database and the mirror server as a primary, without any issues or losing any data. And once we have the primary data center up and running, we can fail over back, and again, all the data changes made in the mirror server will be replicated over to the primary side. The unplanned outage, all of a sudden we lost my primary server, so there's no connection between my DR site and the primary data center. In that case, actually, I have to force the switch and force the failover, and there is a possibility of data loss, because during the time that my primary site went offline or crashed, it could be data in transit or travel between the primary and the DR side that is not being committed in my mirror database yet. So that's the possibility and losing some data, and that's we're speaking. We're not talking about losing the report. We're not talking about snapshots. It's basically, let's say I uploaded a report to reporting services, and that when the crash happened or the failure happened, then that might be the case with that report that didn't really make it to the mirror server. In that case, I might re-upload it again. Last slide, actually, and that's where we upgraded the environment from 2008 to 2012. And with 2012, actually, Microsoft introduced a new high availability feature called Always On. And there are two different Always On. The Always On failover cluster instance, which is not the case here. Then the other option was always on availability group. So this is what we implemented here with the always on availability group, is allowing us actually to have multiple replicas, which is copies of the primary databases. In our case here, it was just one copy of the primary and one copy of the secondary, but we can go multiple if we need to, up to 4 copies. The other thing is actually in this white box here, those 2 instances of SQL Server are participated in a Windows failover cluster services. So you have to have a cluster set up, and both nodes or both instances of SQL Server are a member of that cluster as a requirement to install and configure always on availability group. And the other good advantage of using availability group is it will allow us to use, because availability group is actually a cluster resource, so we can create a virtual network for that availability group. So now I don't have to have a content switch to manage my IP address changes. It will basically just use the availability group virtual network name, and the Windows cluster will manage the failover for me and will manage the name change and actually where my database are active on what instance of that SQL Server. So the front ends remain the same, and they are connecting now using the availability group listener virtual network name. And now my active instances on the main data center, if I lose this, the cluster is aware of that instance went offline. It will automatically fail over to the secondary replica, which becomes the primary, and I don't have actually to use the content switch. I would just need it for the front-end reporting services only. And with that, actually, I'm at the end of this session, and thanks for having us, actually, and it's open for questions, I think, now.
Thank you, Ayat. We do actually have a few questions here. So the first one is to do with the, I think it was when Denny was talking about the Predeployment IO best practices. Eduardo here is asking for that link. And also it seems that in the PowerPoint presentation, there are quite a few links there. So if that's okay, could we get a copy of the PowerPoint as well? That way the attendees can see and go to the links, to the relevant links.
Oh, absolutely. So actually, Julie, I believe the video is going to be propped up in the next few weeks. Do you want us to prop the deck there as well, or we can prop it in the slide share, or do both? Yeah, we're completely cool with having this deck shared for everybody.
Sure. So we do have a YouTube channel. If you provide me with the links that you have listed on the PowerPoint presentation, I could just put them on the YouTube link. That way people can actually go to the to watch the video and then go to the relevant links after on the description of the YouTube channel.
Sure, sure. Yeah, we can arrange both. No, not a big deal at all. No, consider it done.
Excellent, thank you. So we'll follow up on the link of the Predeployment IO best practices. And then there's a question from Kenneth, but I think he might have left, but it might be relevant to the other attendees as well. So when we're talking about the high performance disk earlier on, would it be better if we have SSDs? I think it's probably towards the slide number 6 or something like that.
Oh, right. Sorry. Could you repeat the part about the question concerning the specifics around the SSDs? I'm sorry. Could you say that?
I think we were talking about the high-performance disk, where we have separate disks between the RSDB and RSTempDB. So for this disk separation, I suppose, would it make sense if we actually have, would it be better if we have SSDs?
In some cases, yes, but the key thing about utilizing SSDs is that typically they're still very much optimized for read scenarios or write scenarios as opposed to read and write. Now, some of the newer SSDs actually are very well optimized for both, in fact, but the problem with that particular scenario is that typically you lose a bunch of the disk space on the card itself. So it really depends on the vendor that you're using in terms of whether you're going to use of which SSD you're going to use. For example, in the case of the RSDB, the writes into that are not that often, but the reads are very frequent. So in that case, a read-optimized SSD works perfectly fine for that. There's no, and in fact, if you find that you're having a lot of transactions, a lot of disk I/O because people are hitting that database a lot, in fact, SSDs actually makes a lot of sense. But in the case where it's the RSTempDB, this goes back to understanding the hardware itself, right? If you have cards that are optimized for read and write, you're fine. But don't forget, with the RSTempDB, you have a lot of heavy reads and you'll have a lot of heavy writes. And so because you've got both, right, it's tricky, right? You're going to have to make sure you get a set of SSDs that can handle both, because if it's, for sake of argument, write optimized, that's great. It's able to write the data down really quickly, but then it won't be very optimal for reading and vice versa. Now, do understand the context I'm coming from. When I say optimized for reading, it's not as optimized. I'm talking about in the context of an SSD. It's still pretty fast, okay, when compared to this, but it is still money that you have to spend. So it's finding that right balance between the two. So apologies that I can't give you a straight-up answer. It's definitely one of those. It depends answers.
Okay, excellent. We have another question here. From Greg, does content switch equals load balancer or net scaler?
No, the content switch is not actually. We use the Cisco GSS, the Global Site Selector. It's not a load balancer. It is actually, as we mentioned, it's allowing us to have one alias with multiple IP addresses, with one of them is active. So in that case, when we need to failover, the typical way, you have to go DNS and then change your IP address for that CNAME from IP address on your primary site to the IP address on the DR site, which might take a while actually to flush, and you may need also to flush the DNS, and the workstation or the users will be able to reconnect to the DR site IP address. But with the content switch, which is Cisco GSS, will allow us just basically uncheck the primary IP address, which is the active one, and enable the IP address in the DR side, and that's immediate change. So it will take a couple of seconds, and all of the connection will be redirected to the DR side. But you can have both. You can have a network balancer and also a content switch to manage the IP addresses. But this is not the content switch in this slide, and what this presentation wasn't for an LB, no.
We have another good question here from Travis. How many concurrent users would be considered a good candidate for SSRS farm versus a single instance?
I think you're going to have a variety of answers, actually, depending on the workload. I think, at least from my perspective, general rule of thumb is around 50. But you might actually have a very different answer than I do. And so,
actually, it depends. Number of users also depends on number of reports. So as we have you might have few users but hundreds of reports that access during the day. So loading these reports and cache them and process them, it may be kind of an overhead on one single reporting servers. So as Denny mentioned, about 50 per server, but also 50 per server per number of reports, and how big are these reports. The size of the report is a key as well in determining if you need multiple reporting services. So the client I work for, actually, they have thousands of users, and so far we started with a few reports, and we started with 2 reporting services, and now we're in about to add a third one as we start seeing some overhead. The other thing I also forgot to mention during this presentation, there are execution log views in the reporting server database. These are very important tables where it will show you each report's execution time, rendering, processing, data retrieving. We normally watch these metrics just to make sure we are not there's no overhead on the box, and we can also identify the particular reports that really taken a lot of time, a lot of processing, and with that we decide if we need to add another report or should we move the reports to a bigger machine with more memory and more CPU.
Okay, we also have another question from Sampath. Does the user notice in terms of performance when reports are generated from DR side servers?
Again, when we implement the DR design, we take in consideration the hardware. So we're trying to match the hardware configuration in the primary side to be exact the same as the hardware configuration of the primary side. So even with database mirroring, it doesn't necessarily require to be on the same server level or same memory CPU configuration. We recommended that actually, just you don't want to be all of a sudden failing over to a server which basically doesn't handle the load. So from performance perspective, as long as we match both primary and the R side servers configuration, we didn't really experience any performance issue.
Okay, we have a question from Dimitri to follow up the SSD question. What vendors of SSD would you recommend?
Well, this one's a little trickier because, in fact, I don't want to go ahead and recommend anybody, mainly because it's a little, it opens up a can of worms. So unfortunately, I'm not going to answer that question. I have worked with the Intels, the Fusions, HP Zone, all in the past. Each one of them has their own pitfalls and their own advantages. So sorry for not giving you a straight-up answer on that one.
Okay, no worries. All right, we have a question from Eduardo earlier on, and I'm just thinking whether I could phrase this properly. Okay, let me try. So I think it was around the probably the failover context. In a VMware environment, for example, the sysadmin only wants to give us one VM server to act as a web server and an RDB, but it is painfully slow. So I think the question was, let me just scroll back up here. Would everything that you've been talking about also apply in a VMware setting?
Okay, let me see if I can make sure I'm rocking the question here. So is the question basically saying they've got a VMware setup where the web server RS and RSDB are on the same VM, and so will the advice supplied in this presentation be applicable to a VMware setup? Would that be the correct way of saying that?
I think that might be that might be the closest I could think of.
Okay.
Let me see.
So the quick answer
yes.
is the quick answer is yes. Okay. The quick answer basically is within the context of VMware or any other Hyper-V or whatever type of utilization that you use, all these rules are applicable. The key things when you're working with virtualization is that you want to, number one, set it up so you pass through to disk and that there are specific spindles assigned to the VMs themselves. So that way you are not sharing disks. Now, if those VMs are on top of something like a Clarion or EMC or something, some other SAN type structure, then it'll be just the LUNs are assigned to it. But the context is that way the spindles/LUNs are assigned specifically to that VM as opposed to being spread across the entire disk array, right? If you do something like that, that's part of the reason why you'll see a massive slowdown. Now, it also depends on which version of reporting services you're using. In the case of 2005, there was a lot more disk and a lot less memory utilization. 2008 onwards, there's actually a lot of really cool memory and network utilization, so that you have to also be careful based off of that. But the general rules are basically the same.
Okay, so Eduardo also added here for SSRS 2012.
Okay,
I'm
so for
assuming,
2012,
yeah.
sure. So for 2012, basically, then the context is yes. I mean, everything we're saying is pretty much exactly dead on in that case. Yeah.
Okay, excellent. I think Eduardo is happy with the answer, so that's good.
Okay.
Seeing it's at the end of the hour, would you mind sharing do you have a slide that shows your contact details at all, in case there are more questions from the attendees that they want to follow up with you?
Actually, Ayad, if you can just flip right to the front page, because I think we both put our Twitter handles right in there, so we can just do that. Because I think that's probably the easiest way to get a hold of us right now.
Yeah, no worries. There you go.
There you go. Bada bang, bada boom.
Excellent. Thank you so much, Ayad and Denny, for a great presentation, and thanks everyone for joining today. We have really, really good questions here, and we do have 2 more sessions coming in via virtual chapters. One of them is the SQL Server 2014 launch, so that's on the 13th of March. I think it's at 9 a.m. LA time or Pacific time. Also, don't forget to check our YouTube channel. So I'm hoping to be able to post the session recording by end of the week.
Perfect.
Excellent. Thanks, everyone.
Thanks
See you
very
next
much.
time.
Thank you.
Take care now.